Welcome everybody to the second webinar in the Clear EO webinar series. We are going to look closer to the use of drones, specifically for urban flooding in this webinar. And my name is Bente Lilja Bye. I'm going to be the host. I am one of the partners of Clear EO. And we in Clear EO, we are building applications for urban flooding. That's one of the cases, and for air quality, and also for climate adaptation and resilience in agriculture. The overall or the core technology will be a virtual observatory, and we will develop also a triggering mechanism that eventually will be applied or integrated in Destination Earth. A virtual digital twin of the Earth. So today we have the program of first introducing you to a little bit more information about the urban flooding use case that we have. And then we will learn more about use of drones in rapid recording, monitoring in the case of an emergency. And unfortunately, the speaker from the Norwegian Water Resources and Energy, he left to me to do the presentation because he's out in the field doing the field work. So he's a very active person, but I got his slides and some explanations, so I will do my best on his behalf, Simon Oldani. And then last but not least, we have Piotr Zaborowski from OGC. And Elena Durando, one of our partners, will give the presentation on the flooding and also on use of rapid monitoring with the drones in Italy. So with that, I think that we can start directly with you, Elena, that you can introduce us to the urban flooding pilot that we have, or the application that we are developing.
Yes, sure. Good afternoon, everybody. I am Elena Durando, and I am a geographic information system specialist, and I'm involved in the ClearEO project for the urban flooding application. And I work for ITHACA, a company made up of a multidisciplinary team from different backgrounds, specialized in geospatial solutions. So we carry out Earth observation and cartographic projects, and we are also involved as production sites in the Copernicus rapid mapping service that I'm going to present later. But before talking about it, I'd like to present you what we are building in ClearEO application on urban flooding. So this flood application aims to develop an on-demand forecast of flood extent and water depth in urban areas. How? Thanks to the integration of different forecast models and data sources focused on extreme rainfall events, and building a digital surface model of the urban area used into a urban flood model together with the drainage information. So starting from the detection of extreme weather that is based on different forecasts and meteorological satellites, the system will detect exceeding thresholds precipitations at a regional scale first. When this heavy precipitation event is detected, an on-demand urban flooding workflow is then triggered. And this workflow integrates also real-time observation and satellite observation at a local scale. If also the local scale observations will confirm the high probability of extreme rainfall, then the urban flood model will be executed using the precipitation forecast of the previous components and the digital surface model of the urban area together with the drainage system that will be integrated into the static flood model. The flood model's output will be then disseminated to the end users in the form of flooding scenario maps with the flood extent and depth information. And in this way, we hope to help the risk management, the flood risk management phase. In all this workflow, a notification system will help the communication between the different components by the exchange of the triggering signals. So, for example, the exceedance of the precipitation thresholds. Yes, here you can see a summary of what I've already said. So the forecast will be tailored for the urban area. We'll give any information about the amount of rainfall. The urban drainage aware warnings will let us know the amount of surplus rainfall, and the digital surface model will give information about the water flow direction and water depth. And all this workflow will be built to quickly create easy to read flood inundation maps to visualize the streets and buildings at risk. Why we do it? Because cities are facing an increasing in population and also in the extreme events due to climate change. So the need for more accurate early warning system is increasing, and we need this information for improved risk prediction and reduction. So we would like to build a decision support tool more than a forecast system designed for the real challenges of the urban areas, and designed also to explore maybe a future integration with the Copernicus emergency framework. So now we can go to the very topic of the webinar, focusing the attention on the integration of the real-time data from aerial components to improve the flood monitoring and the fast elaboration of data. So within Clerio, we are interested in how multi-source data can enrich the monitoring system and can bridge the regional scale with the local scales. So today I will present in around 8 minutes, I hope, a very specific operational context that is the use of aerial components within the rapid mapping workflow of the Copernicus Emergency Management Service. So rather than presenting the technology in general, I will show when and why these components are actually activated in these real emergency operations. I'd like to make a quick overview of this rapid mapping service. It consists of an on-demand and fast delivery of geospatial information in support of emergency activities immediately following a disaster. This service is based on the acquisition and fast processing of imageries and other geospatial data, and can be activated for different type of disasters such as floods, but also wildfires, landslide, volcanic eruption, earthquakes, and so on. And it is a global service that operates all year round, 24 hours per day, and is part of the Copernicus program, as I said before, so it is directly managed by the Joint Research Center. The rapid mapping can deliver different products depending on the user needs. One of the most requested is the delineation product that provides an accurate assessment of the event extent and is delivered in 7 hours. Another very request product is the grading one that provides not only information about the event extent, but also details on the damage grade of buildings, roads, and all the infrastructures, and is delivered in 10 hours from the image reception. As you can understand, the rapid mapping is primarily based on satellites. So, for example, during a flooding emergency, the SAR imageries are the backbone for the delineation product. So, for the flood extent and flood depth mapping, while the optical satellites are used when the cloud cover allows, especially for the grading maps, so for the damage assessment. Satellites are the base for rapid mapping because they, in the emergency phase, the priorities are the coverage, the speed, and the consistency. So airborne components are not standard, they are exceptional, but in specific cases, airborne imagery can address some challenges. In fact, satellites have some limitations due to, for example, persistent cloud cover or need for a higher level of detail, especially in urban areas with complex buildings and so on. And in this way, the aerial imageries offer the spatial resolution that allows for a very accurate analysis. And so the aerial component can complement the satellite data, improving the overall accuracy of the grading products. They are rarely used in rapid mapping, not only because they cover a smaller spatial area, but also because a matter of time. In fact, before carrying out any activity, emergency activity with the drones and the aerial components, the Copernicus team must ask for the permits from the local and national authorities, and so this process slow down all the workflow. Now I'd like to present you some real cases, some real activation where the aerial component have been used. The first one occurred in November 2022 when a strong cyclone hit the central and southern Italy. And these heavy rainfalls triggered a very large landslide on the mountains of Ischia Island. This landslide claimed 12 people's lives and affected hundreds of buildings. So the Italian Civil Protection activated this rapid mapping service to support the rescue operations and to help quantify the damages. And so the rapid mapping team first delivered the delineation product that is the one on the left, based on the satellite acquisition to evaluate the extent of the mud flow. And then, since this region, this area was particularly steep and it was difficult to understand how this landslide moved, an higher resolution would have been more useful. So the aerial component was activated. And on the right, you can see the grading product based on this aerial data that detailed much more the mud flow that covered a total area of 30 hectares. And also the damage assessment identified around 220 buildings affected, and 27 of them were classified as destroyed, completely destroyed by the landslide. Another activation involved the Emilia-Romagna region in Italy in May 2023. The rapid mapping was activated to assess the extent and the impact of this flood. So during the very high phase of stage of the emergency, the SAR data provided the regional situation of flood. On the left, you can see the delineation product with the flood delineation, and help during the first emergency phase. Then the drone component was used to acquire high-resolution imageries over several areas affected by landslide, which were critical to the civil protection. And these data were crucial for producing the landslide characterizations and volume estimation, including a very small landslide in several remote areas that affected the buildings and the roads in particular. The last activation I'd like to talk about is the weather system that affected Portugal in these very last weeks, because this February, a period of heavy and persistent rainfall, strong winds made an hydrological damage in several river basins in Portugal. So as you can see, there were 18 areas that were hit by these strong winds and these rainfalls. And the rapid mapping service was requested to provide the flood extent and depth and the damage assessment. So first, the delineation products have been delivered in these 18 areas with satellite imageries. And then the user requested a particular focus on the municipality of Leiria, with attention to buildings, roads, infrastructure, electric networks, and fallen trees. So you can see in green the area that was analyzed with the satellites with the flood depth and flood extent, and then the red dotted lines are the smaller areas that have been covered with the drone flight. And while we are talking, the rapid mappers are working with these imageries and are assessing the damages in these areas, so they should deliver the grading product in the next hours. So to conclude, some key takeaways. The satellite data are the backbone of rapid mapping flood, but aerial components can be strategic in some specific cases. Their main value lies in bridging the scales and, of course, during the grading of damages. And their innovation is not the sensor itself, but is the integration across scales and phases of the emergency. So we can definitely say that the aerial components complement the satellites in the rapid mapping workflow, and yes, where the satellites have their limits. So satellites see everything, drones see this better, but our job is to make them work together. And thank you for your attention. And if you have any questions, I'm here for you. Thanks.
Yes. Thank you so much, Elena. Absolutely interesting and impressive that what we can actually do. Elena, I don't know if you know this, but you said that some of the problems that is related to using drones is to getting permits. And the service that you describe is across many, different countries, right? It's a service
Yeah,
different countries.
yes.
And so I imagine that there will be many different rules and regulations to relate to. Do you have any additional observations related to that?
Yes, while the rapid mapping is a global service, the aerial component is at the moment European. So it is activated only in European countries. I know that the Europe is trying to make a common legislation, common laws on the use of drones, but it is still hard to do it, to ask for these permits in a very fast way. So I know that the Copernicus team is working with the national aviation authorities to find a way to simplify these requests and to fasten the process. But yes, it's still an ongoing process.
Yeah. Any other questions? I started the ball.
I have a question.
Yes,
Or if
Georgios.
somebody else raised his hand, but maybe okay. So I have two questions. Is there so there is also an in situ team where you collaborate in order to provide this?
No, we provide this map for the civil protections that, of course, works in situ, but all our works is done remotely, so with imageries and satellites. So what we know is that after when the emergency phase is finished, the civil protection give us a feedback, not to us but to the Joint Research Center, regarding our work, if it has been useful for them, how accurate were the analyses, and so on. But we don't have operators that are on field.
Okay, thank you. So having a UAV just after the UAV flies just after how to say, the damage after the danger has passed, correctly?
Yes and no. The aerial component, the European aerial component, has some agreements with the drone operators that can be asked to that can be activated when needed. So they are activated when the emergency phase is ongoing. But due to this slow process in the permits, they can fly it not during the real emergency phase, because also of
Yeah.
weather limits, but
Yeah,
yes, so immediately after.
this is clearly stated in the EASA regulation, the European regulation, that you cannot fly the UAV when there is a danger or a specific situation.
Yes,
So maybe this is also a conflict too. Okay.
it is
Thank you.
for, yeah. What?
Yeah, thank you, Georges, for those very good questions. And hello, Grace. Nice to see you again. The floor is
Hello.
yours.
Thank you, Bente. Can you hear me okay? Because I had to change my my mic and headset. But I just wanted to ask a question about your integrated workflow. If you could just speak to that a little bit, just to explain what that looks like and how that works together.
You are talking about the workflow of rapid mapping or the one of
Oh, when you talked about integrating the work, like trying to create that bridging between the satellite and the drone in your workflow.
Yeah, yeah. Yes, this workflow is maybe I can go back to yes. So talking about the rapid mapping service, I was telling that the bridging the scale means that with the satellites we can have a regional awareness of the situation because we can know at a regional scale what's going on. But of course, because of their limits with the resolution, for example, we can't understand in complex terrains or complex urban areas what are the damages and what's the situation in this complex situation. So the drones can be very useful in this second phase, that is the damage assessment and the grading of these kind of damages. So I said that this multi-source data can be a bridge between regional and local scales in this sense. So from a larger view to a specific area.
Okay, thank you. Can I just also ask, like, what triggers the decision to go into, say, using the drone? Like, at what point do you say, well, we need to engage this higher resolution data? So what are those scenarios?
Yeah, this is a decision taken from the Joint Research Center in accordance with the authorized user. So when they understand that there's a particular area that with the satellites is not, where satellites are not enough to cover and to understand what are the damages in these locations, the authorized user can talk with the JRC responsibles, and they can advise for activate the aerial component that can help them with the rescue and damage assessment. Yeah.
Great. Thank you.
You're welcome.
Yeah. Thank you. And for those who don't remember what JRC stands for, so it's the European Commission's Joint Research Center, and they are serving the European Commission. Just
Thank you, Bente. Yeah.
I know it's the acronym SUPA.
Yeah.
Okay, thank you so much, Elena. And now we are moving to Norway. Simon, he knew that it was a certain danger that he might be out in the field, so he provided me with the slides, and he said that he gave me permission to present the slides on his behalf. So Simon Oldani, he is the operating manager of the drones at the Norwegian Water Resources and Environment and Energy Directorate. And before we start with the drones, let's then explain, for those of you who don't know this type of organizations. It's, let me see. Well, the title is NVE is the short name for this organization, From Drones to Decisions. And this organization is then responsible for and is the authority for water and energy resources in Norway, and they manage water. They monitor flood and landslide hazards and provide hydrological data and help ensure a safe and stable power supply. You probably know that Norway is very much reliant on hydropower. This is one of more than 90% of our energy comes from hydropower. So the drones sit on the natural hazard side of the mission, so field work, like Simon is on right now, measurements and documentations. And they are not a blue light service, but they are very often early at the scene all the same. So specialists get a precise basis and better situational awareness. So why use drones? The nature behaves in very different ways. So some sudden processes like flood and snow avalanches, you have that in Italy as well, I guess. Every now and then in the Alpine region. Quick clay landslides, like Eleni was also showing some examples of landslides, and even debris and earth slides. So in these cases, it's necessary to move fast and to document and measure and give the technical teams a clear picture of the situation. And in some situations, it is also possible to keep live video flowing from a drone directly to the emergency room, for example, where to look at how the flood is unfolding. Here is one of the latest extreme events in Norway. We called it Hans. We all have names for our extremes. In the Norwegian, this is Hans, it's a Norwegian name. And you see here a map and an overview of the event as it expanded. And it affected a very large part of Norway over several days. It was high precipitation, rising rivers, and widespread flooding, and it created a rapidly evolving situation across multiple regions at the same time. So to understand the scale and development of the event, early and reliable situational awareness was essential. So apologies for some of the Norwegian, but you see what you should look at here is the situational map. This is for Avinor, so the aviation organization in Norway. So large part of the airspace were actually closed. So however, NBA, so this organization, was granted permission to operate drones where it was necessary for public safety and technical assessment. And drone operations provided rapid overview in areas that were difficult or unsafe to access from the ground. So through systematic flights, they documented floods, extent, flow path, and the development of the situation while the event was still unfolding. And I think, as an add-on to the question, a report from Elena here is that what Simon told me, that he was actually negotiating with people that he knew in certain places to get permits to fly. So Elena, getting this, these regulations that you're talking about on a European scale, on a very local scale, it might actually be possible to get this permits to fly the drones. I think that was piece of interesting information. Now, I will show you a video, so you will see how the flooding is looking like. Do you see it arrives? It's black still?
Yeah, of course, still black.
Okay, let me see if there you go, right?
Yeah, now we see it. Thanks.
Yeah. So it was in August 2023. And this imagery was not used for real-time situation awareness. This is just after the fact. But the value increased even further in the work that was followed. So even this video recordings from drones has a value afterward. So by analyzing images and videos, we identified then visible watermarks and clear references point in the terrain. By the way, this is the city where I went to school. This is my neck of the wood in Norway, by the way. So this is funny for me to see these recordings. This is well-known terrain for me. And you see here the challenges of measurements. The observations, however, made it possible to measure specific locations and determine how high the water actually reached. And we have discussed this in Clerio, that it would be good to have the water levels during the event to improve the service. And because the imagery was geo-referenced, the measurements could be linked directly to terrain models and known elevation data. So the data that could be used directly in further hydrological and technical analytics. And you see that there's a combination, you know, that Hans was so immense. You see that it covered both land and also cities and urban areas. Since we are covering urban areas in Clerio, I thought that was important to show. So here is then some measurements that is done in various areas. I will go, this is in Norwegian, so I will just skip this. The only thing is that it was a joint effort between different departments or ministers, and that ensured a situational picture, an overall good situational picture, and stronger technical basis for assessment and decision making, which is important for us. So what matter most for this service at the Norwegian Water Resources and Energy Directorate is drone operations isn't the flying itself, it's the data they produce and the technical value it creates downstream. So thanks to the drones, it's possible now to provide data that was previously slow, costly, and practically impossible to obtain at this level of quality. So these data sets are accurate, consistent, and provable, and enabling experts to analyze, to simulate, and respond effectively to natural hazards. In practice, that means that they can produce terrain models that goes directly into planning and design of protective measures, so prior to events, document the development of floods, landslides, and other incidents, and also give geologists, hydrologists, and engineer a factual basis that makes a decision safer and more targeted. So this system, drone flying, and this service is part of a society, the Norwegian society, total preparedness. So because shared data creates then a shared picture of reality when several actors need to decide together. And here you see some locations where this data is collected, and the situational awareness is a fresh procedure. What was correct yesterday isn't necessarily correct today. And they see clearly in practice that they produced about 150 data sets across 15 locations in Norway. You see it distributed along the country. With repeatable surveys, you can measure change over time, not just see it. And here is an example. Here comes an example from a landslide that was horrible. It was in 2020, and it was a quick clay landslide, and that transformed you see the houses and the community within minutes. And 11 lives, you see here, is very damaging. 11 lives were lost, and over 1,600 people were evacuated, and the terrain was completely changed. And standing there, he says, because he was there, Simon here, and it was very hard for him to describe, and the sheer force, the scale, and the speed. I can only imagine being there. So in the acute phase, the Red Cross, fire and rescue, the police, and the Norwegian Water Resources and Energy Directorate worked very closely together. A textbook moment of total preparedness that was emerging on site. Fire and rescue flew drones continuously to monitor rescue crews in the landslide pit, And the police had the coordinating role and used both drone data and technical assessment as decision support. So NVE here contributed expert knowledge on stability and ongoing risk. So when they started to do their own drone flights, they did so under clear agreements. Fire and rescue flew at 80 meters AGL, and NVE stayed roughly 20 meters higher. And so everyone could work safely in the same airspace. So obviously this requires quite a bit of coordination and trust. So from there, the focus, NVE's focus was on 3D models that the technical team could work from. And the very first data set delivered by external providers were important, but expensive and slow to arrive. So NVE therefore built an in-house capacity quickly so they could deliver fast and more continuously. So to tie this together, this isn't really about the drones, he says. It's about how to gain overview and how to understand what's happening and how we make decisions stand over time. And situational awareness is fresh produce, and what was right yesterday may not be right today. And that's why it matters how fast we get new comparable data and whether it can be shared and understood the same way. When it works, it's because roles are clear, responsibilities are understood, and technical teams work together. In Gjerdrum, you know, the rapid clay slide, it was crystal clear. Fire and rescue, the police, the Red Cross, and NVE, different roles, one goal, and a shared situational picture supported by drones and coordinated sharing. And much of the preparedness also lies afterwards in the follow-up, documentation, learning, and then the ability to stay with the situation over time. So that's where this directorate, NVE, air operation fits naturally. And they are not always first on the scene, but they help decision makers in the acute phase and long after, and work from the best possible shared pictures of reality. And this is, he thanks you for your attention, and so do I. So you see how it is. This is like operational service and operational activities is slightly different than what we are doing when we are doing research. So that was it from me. Let me stop sharing. Yes.
Thanks a lot, Bente.
So let's see. Do we have any questions? I mean, before I was BLB, I was actually a research director at the Mapping Authority, and the Mapping Authority do also roles in early warning, etc. So I do have some competence in addition to what Simon here revealed. So if you have any questions, I might actually be able to answer. Piotr Zaborowski is the one who will slightly explain to us how all this can be put together and how necessary and important it is with standards and best practices and the challenges related to that when it comes to drone. Perhaps, Piotr, the drone data is regarded as in-situ data, and in GEO, the Group on Earth Observation, we are specifically targeting how we can have good data management and make data interoperable. And Piotr has already been working on this for quite some time. So Piotr, we are eager to hear you telling us about standards.
Yeah, thank you very much. I will try. Let me know of any questions. I mean, yes, drones data is actually considered in GEO as in-situ data. Sometimes it's not. Depends on the height of the drone sometimes. But I guess one of the ideas that it doesn't necessarily matter in some cases, if that's what class is that, if that's supported by the by these good practices, like simply using the standards. And yeah, that's showing the background, the OGC, the Open Geospatial Consortium, which I now work on, and represented here is the association which is working for these topics for a couple of years, more than I'm working, maybe even almost the same. But yeah, there's naturally the legacy of these of this work and the standards and good practices, but naturally it's changing and evolving. So things that doesn't change is the number of numbers, and the number of the data is naturally even more growing even more. You have these drones here. There are these digital twins, which generates even more data. Not talking about any other and future generative AI and this kind of tools. And what we hear recently is that we've been talking about the machine readability for years, and now it became sometimes the challenge to make to assure the human readability of the data, and the challenges of fair data. I guess we are moving towards that, but that's also the moving target, thanks to all of this. Thanks to all of this progress and all of these drones you have and produce the data for so many cases and for so many tools. So the common patterns also is maybe not changing that much. There are some changes which we observe here in this data flow, and just few standards that could be like attached to this different points of the data or the value stream. You probably know some of them. Some of them maybe are emerging, and some of them are just conceptual, like this integration with the AI is something that doesn't have yet the maturity. The changes which we observe are naturally related to the cloud storages, and here you have, for example, this movement towards cloud native formats. It sometimes works, sometimes not. What we have seen is that these community standards play increasing role in the ecosystem. The community standards, as for the OGC, they are actually standards. Just they are coming from the community, so there's already kind of good adoption of this in the ecosystem, and then they just go through the process of harmonization, which I'll explain the reason for that in a second. The other thing is that we have this traditional value stream from the acquisition to the added value services and optimization for the web services, all of the stylings services that you use, data streams that your application is triggered, for example, for the warning systems, is optimized for these cases, and it's also sometimes optimized for this degraded environments, remote environments, which doesn't provide a good connection or maybe unstable connections. The other direction, on top of this, what I said, cloud natives, optimization, the volumes, is that more and more integration is going backwards to the data sources and the control of the data acquisition, which could be either human-based and requirements-based, like we have seen in these data requirements working group, geospatial observation needs and requirements. So working group is now set up based on the work on the in-situ requirements, and the Connexus system is more like system-to-system integration example, where you can actually integrate this data streams together. And the good thing is that all of these standards, either it's coming from the community and it's aligned to some good practices, or it's like a fully fledged standards developed under the standardization roadmap. They are somehow referring to this good data models, to the common data models. So you don't really have to care that much if you select any of these standards. Is it conceptually consistent with what is in the other standard? Naturally, there will be differences. Each of the standard has the role, and there's no like sweet spot, maybe one fits all solution that solve all of the issues. But you can connect them together. So, for example, when we observe this Connexus systems, the name is not accident. It's actually connecting not only systems like IT systems and remote systems, but it's also connecting these different standards together. It's building on top of many of them. As here, just example, if you care about observations, you probably use some deviations of the SOSA, which you could be not aware of, but it's often the case. And then if you care about the movement, you can also attach this second level information about about the device. Is it useful for the data processing, or is it useful just for the operations of the device? It doesn't matter. Oh, I will show everything here. And the story of the connected system is actually coming coming from several years ago established interoperability experiment. Just few people came together and decided that yes, we need to see how we can support better interoperability between these unmanned vehicles. At that time, it was not only UAVs. Some of these organizations are focused on the aerospace. Some of the others are more focused on the marine, but the paradigm was the same. So they wanted to have like a common model for this operating of the systems, and they created this interoperability experiment, which then transformed to a couple of working groups that all is connected in this standard, which is evolving. It's multi-part standard, so you don't have to implement everything, and naturally, not all the standards are yet connected, but there are many of the pieces already put together. So, as I said, it covers any kind of device. In this case, it's UAV. So, whatever you are really do care under the interoperability, you can select pieces of that, connect the systems, and use it. Is it the device itself and the control of this device, or the information over the route, over the flight, after the acquisition, after the mission? Is the information about the sensor? They have revised the sensor ML, which was quite rigid XML schema. Now it's more flexible and more modern, aligned to these APIs format. And then you have the data itself. So whatever you actually acquire is kind of what we call features representations. It's also something which is coming from ISO and OGC together. And then you have these different presentations of the data. Is it the image like cloud native GeoTIFF, which is optimized for the random access, but also contains some metadata information about the geolocation, etc.? Is it the new community standard like GLASS, which is covering the LiDAR data and cloud points? Is it very specific format like Jimmy, which is just coming as the NIST standard from the US, designed for the defense and intelligence, which contains also a lot of the metadata information together with the images itself? And you have some additional functions like the control itself. So all of that is connected systems. There are specific functions that the standard itself is providing. Just as a reference, I will not go through that, just to show you that what areas does it cover in the from the legacy work, and also the same case for this. Just to give you the overview, what was the year ago support of the different standards on the different interoperability points, and as you see, a lot of the standards actually not core connected systems. They are just supported by that. And then we come back to the general questions like why do we care about that, and how do we do it, and what is the right set of right balance of strict specifications and the knowledge technologies. So now you have this drone data, which you integrate with the Earth observation data. From the remote sensing, maybe you will have the in-situ data either for the validation or marking points or whatever you use to actually geo-position your data. In the cloud, the idea is that you have it from whatever sources possible, and then you need to understand what is in the data, but you also need to process it fast using your tools that normally is in the operations. So the contextualization still matters here, and naturally it's not only the context about the geolocation. As usual, we see that there are multiple layers of the same scene and multiple data types and data representations, but it's also contextualization of time and space, and the context of what was actually done in the processing of this data. And based on that, only we can say, can we generalize any of these rules for the conceptual world models, or we just observe, the thing which are happening and we're observing at the moment. And then we do it for years. We probably some of you already benefited from the interpret that was developed through years. We are continuing this work in this space, and this is not the technical effort itself. If it would be technical effort, we would see only increasing complexity of these standards being not connected to each other, not aligned in different aspects, etc. So it's also the community work that you can do and you are doing in some cases to agree on some concepts and to just formalize them. Is it the formal document, or is it the template or the schema or the good practice you are sharing? All that matters, and all is, if well developed, it can be connected to this generic terms. So here is just the example of what we have developed recently, actually proving that many of the standards which are coming from the communities, is it the chemistry, it's from the marine case in this slide, but it can be it was adopted also in the green data space and agriculture. So the same concepts in the central are reused by the different flavors of the data that's simply based on the common definitions. And it must be flexible. So not to forget that we shouldn't define very long standards, multi-pages, which actually rarely everybody can implement. The idea nowadays is more like we are defining these pieces that everybody can combine as they need. So coming back to the UAV case, you don't have to support all of the functions of the connected systems to say that you are implementing part of that, and then based on your if you follow the standards, you already have the declaration of what you are supporting in this machine-to-machine way, so everybody can actually see, okay, you have provided this kind of functions, and I can use it in this way. Coming a little bit down to the details, in the very specific cases of your domain, you will observe this. Well, you already do it in this early warning systems. So there are the indicators which you observe, the conditions of the environment which you rely on when you try to model and forecast what will happen, and also allows you to operate in the field itself. And then if you want to extract the knowledge from that, you will have this, for example, flat related indexes, and that is good if that's coherent also between the cases, and the best if it's coherent between the community, which means that once you have the standards, which is per definition the geospatial standard, the ISO standards, in many cases are abstract from the domain, then you need to build on this on top of this the specific information level, and for that we have built this kind of methodology which allows you to define, okay, I have the specific terms and the specific properties do matter for me. I don't need to follow the whole Inspire, which will be in future obsolete, maybe, or maybe it's not covered in the Inspire or any other standard. You can extend it easily. So there are the examples, there are these validators you can use, progressing towards this 5-star model of the semantic interoperability and technical interoperability. And just few ideas. What could be the next steps? We are naturally moving forward with the standards itself as the community, but also in this kind of projects like you are doing. We are happy to observe like what are your actual pain points? So I spent a lot of time talking about the connected systems. It's not for everybody, for sure. So if you are operating your end, kind of maybe not customized devices or something which is coming out of the box, connection, the command and control panel and so on, you don't really need to implement the connected systems on this C2 level, but on the data acquisition, when you push it later on into the data lake, data hub, federated system, even more, you need to support some level of interoperability. So we are happy to also listen to your requirements and real needs from the field. For sure, there will be more and more this rich data streamings. There's like a couple of standards for the LiDAR data. It's kind of similar. So there's a couple of standards which are present. The community which was around the OGC decided that first they will do with LAS and treat it as the reference for the next ones. But that can change, and the work on the indicators is naturally something of our close to our hearts, because it is the core of the semantic interoperability in many of the cases that we want to really extract the knowledge of the world system based on the observations we are getting. A little bit of this governance. Naturally, there's a challenge of governance, both on the standards, the profiles of the standards, what you have defined as your standard in your project, for example, or in your community, and how does it link to the others. So technically, we are investing in that. Naturally, it's even less technical work. It's more like a community effort. And with that, happy to have your opinions on standards and what could be done good. How can we help here?
So thank you so much, Piotr. And it's very good that we have you on our advisory board in ClearAO, so we can dive even deeper into that, should that be necessary, and it might be. Any questions directly now for Piotr concerning the standards and his presentation? It was all crystal clear, was it?
Probably, yes.
Yeah, probably.
I have a question. Thank you for the presentation, Piotr. So, based on the work you do also, I saw there is also so much detail in the information. So, if you describe semantically the field of view of the camera of the UAV, you do this, I suppose, in order to standardize, let's say, in order the model to be agnostic of the sensor and the model of the camera and the UAV. I suppose this is the goal. So you can describe some very specific details, very specific properties, independently of the model or the camera model or the UAV model. Is this correct?
Yes, to some extent. I mean, there is always this abstraction model which you can extract, and the details which you cannot, and they are very specific to the device. So I mentioned that this SOSA model in general, which all of these other observation systems are based on, is defining the several entities of the data stream, of the sensor, of the properties. And then, yes, the data stream is focused on the data itself, and it gets as much information as is specific to the data stream, while often the observer property contains more details of what you are actually measuring, also about the quality of these measurements. And then you go to the sensor information, which could be very specific and very data type specific, but also the measurements specific. So I guess yes, the whole idea of this interoperability is that there are certain level of information that could be supported at scale by many tools, and there will be always something on top of that. Always. Is it the domain specific? Is it the model specific? Is it the acquisition specific? Doesn't matter really. And that's why the standards are trying to factor out the abstract model, but also be open for these extensions. And naturally, all of this, the standards allows you to add additional properties, which then you need to agree with your community sometimes, or with your provider. So naturally, if you particularly do the connection to the UAV system, it will be different from the ground uninhabited system or the marine one, and they can not be supported on every corner of the software, I guess. Does it answer your question?
Yes, Georgios? He froze.
Don't. Apologies.
Are you come back, Georgios?
Thank you. Yes, I'm back. Thank you.
Oh yeah, you did. Did you answer the question? We didn't hear your answer to Piotr.
Yes. Thank
He
you.
answered your question. Yes.
Yes.
Okay.
So communities that have, let's say, stronger communities have, let's say, a head start in this sense.
Yes, communities and companies, and that's one of the challenges that sometimes, the awareness of the need of the standardization is coming after the technology is developed, and then you need to somehow support this in a way it's well done. So yes, the need for the connected systems, for example, was coming simply from the clients of these data providers, which wanted to have like sustainable information system, regardless of who is providing the data. So would I select in the next, in the next years, this provider or the other? I don't change my software because I require them to be aligned with our standard. Yeah. And then it gives you more flexibility also. And naturally, the need is more, let's say, visible on the entities which are procuring these contracts. So naturally, there is a strong support from the governmental organizations, which are clearly aware of that and simply are not producing data themselves often, and they need this kind of support. And on the other side, also, they are buying the software, and then if that is compliant with the standard, they can change also their analytical system or the data storage or their applications. It still remains at some level compliant with the standards, meaning that it still can be, replaced. You don't have this vendor lock-in. So that's like negative aspect to avoid the vendor lock-in. The positive aspect is that once you have the standards, like for the downstream data, so you have the data coming from the remote sensing, the UAVs camera, for example, and then you put it together in your data lake. If that's aligned with some standards, it's very easy to process that data in the same way, on the similar way. So you have this multi-resolution support. You have, basic things like geocoding, the coordinate system supported in the coherent way, or at least you know what is the coordinate system. And then is it the analytical tools, or is it the web service or the applications? It's much simpler to connect to this data. So it works on both ends, data acquisition and the analytics, I guess.
Thank you. Thank you.
Yeah, so I think that what we've seen here or heard here today is that including drones is, I mean, it will improve the service. That Elena was starting to say, why are we doing this urban flooding? It's not just to monitor, it's actually to deliver a service that can be used for decision making. So that's the motivation. And then Eleni also presented this rapid mapping, but still demanding in terms of being rapid enough. I would say it's sort of, the way I hear it is sort of a intermediate rapidness compared to what the directorate in Norway, the Water Resources and Energy Directorate, NVE, they were even faster in, and they said even that there were several providers of drone data to get the situational overview, and they decided to do the analytics themselves because the other provider of data in this context were not rapid enough. So Piotr, if they had spent time on using the same standards, they would be able to actually have a richer, faster analytics based on those drones. So I think it was a very good covering.
There's also one more point. The standards which some of the organization are using are closed, and some of the others are proprietary. What we are proposing is simply the open standards model, where the community owns the standard, meaning that it's not dependent on the single provider. So if you connected all of your system to the Maverick protocols, for example, you can work as long as you are happy with the providers which are supporting that. But you have like little influence and little clarity of the next, I don't know, 5 to 10 years, what will happen with this protocols and the support, and is it really safe or not? So that are also the concerns of those who initiated the work years ago, and I guess it's all beneficial to us. I started working with the standard really from the uptake perspective, and that was really useful, putting a few pieces together out of the box software, either closed or open source, and you could do really fast start into the field.
Yeah, so I'm sure we will look closer on these standards and see how we can potentially integrate it in Clario, even to see if it's possible, maybe to use, I mean, what you described also. I think you included that, Piotr, the data spaces that is also controlling the access and having this connecting points, etc., etc. So, and that's highly relevant when you have like an emergency or a real-time event, because there are some sensitive data. So you need to have very good control of who is getting what kind of data. But that's, this is also what we are considering. And this is why we also wanted to organize this webinar to explore how potentially we could integrate drone-based data to enhance the service.
Yeah, I guess this is very, very important to consider really for UAV data. We are going into this personal data protection strongly, and the sensitivity of the data is extremely high. So yes, that's why we also, I guess, not observing many of the existing, repositories of the drone data as in the Earth observation, for example. And that is something to be changed, I guess. That would be good to be changed.
Yeah. Okay. Do we have any more questions before we close? No. I forgot to introduce the coordinator of Clerio, which is Link Foundation, and we have Paolo and Virginia here with us. I don't know if you will say hi. Yeah, waving is good.
Hi, Bente. Thanks. Sorry, I'm trying to make me visible in the camera. Now it's better.
You get an aura around you, like a halo. Yeah. So if I don't see anything else, we are 1 hour and 20 minutes is good. Thank you so much to all the speakers. I'm very happy that you could make it on such short notice. We will see you again in the next webinar, which will be in a month's time. So stay tuned to us.
Thanks a lot, everyone.
Thanks, everyone, to the speakers, and thanks, Bente.